In this video, I want to go over last week's assignment that dealt with calculating the expected mean or expected cash flow, or what one would anticipate receiving, and at the same time being able to come up with the expected standard deviation and the coefficient of variation. In business, the coefficient of variation is very, very important, which I'll talk through when we go through these calculations. But remember, one thing in business, in any business decision, is that we like certainty. In other words, we don't like to take on undue risk. We like complete certainty. So therefore, you might have heard the phrase risk adverse. Well, in business, we are risk adverse. We would like to know with, say, complete certainty what our profits will be, what our sales will be, what our cash flow will be. And this is why it's important in this assignment to kind of get a broad overview of how we would calculate the expected cash flow and how we would calculate the standard deviation. And if we had more than one project, like should we go with Wrigley or should we go with Crosley, which one should we go with if we do have this risk aversion? So first of all, let's just kind of look at Wrigley here. You can see in Wrigley, we have in the first column here, we have some possible cash flows. 10, 30, 40, 50, 60. So what this is saying is that we've come up with some scenarios. $10, $30, $40, $50, or $60. And with each one of these possibilities that I have assigned a probability. 10, 20, 30, 30, and 10. So really what I have here is a probability distribution. So to come up with the expected bond return, well, that really should be expected cash flow, since we're dealing with cash. So ignore that bond return. So basically what we're doing to come up with the expected return, or in this case the expected cash flow, is to simply take what we would expect receiving. In this case, one scenario we expect $10, and we think that there's a 10% probability. So $10 times 10% would be, of course, 1. 30 times 20% would be 6, all the way down the line. To find out what we expect the cash flow to be, for this case Wrigley, we would simply sum up the probabilities, i.e., and we would arrive at 40. So what this is telling us, cash flow times the probability of receiving the cash flow on any particular scenario. So here we have 1, 2, 3, 4, 5 scenarios, and we've done the calculating. So that's what we would expect is 40. Now, in regard to the standard deviation, the last column here, let me just kind of follow through, and you may want to have to go back and review this video. So what we are saying here is that we know what we are going to expect, 40. So in this case, to come up with 90, we will go to our first scenario, and we are saying, okay, 10 minus 40, 10 minus 40 is 30, right? We're going to square 30, and we're going to come up with 900, and we're going to multiply that by what we think the probability will be, 10%. So that's 90. Once again, just let me repeat that. What we are doing, we are taking the cash flow from the first possible scenario. What we think we may have is 10, and we're going to minus that by our expected. 10 minus 40, we're going to square that, that's 900, and we're going to multiply that by the probability of what we would expect this cash flow to be, which is 90. And we would take that all the way through for each one. We would come down here and we would sum them up as I've indicated here, and the sum is 180. That is not the standard deviation. That is the variance. That's the variance. To arrive at the standard deviation, we would take the square root of 180 and we would come up with 13.42. The coefficient of variation, which as I indicated was very, very important in business decisions where we have to make a choice between, in this case, Wrigley or Crosley. Which one am I going to go with whereby I have a greater certainty of receiving the expected mean or the expected cash flow? The coefficient of variation is simply to take the standard deviation, in this case 13.42, and divide it by 40, and that gives me a coefficient of 0.34. 0.34. By itself, if I just had to, say, analyze one particular investment project, the coefficient of variation is not really going to tell me that much. Yes, it's a computation. However, we utilize the coefficient of variation as a measure of risk, as a measure of uncertainty when I'm focusing in on more than one investment. And I have to make a choice. Which one do I take? We will always take the one that has the lowest, the smallest coefficient of variation, because that is the one where we have a greater certainty, a greater probability of earning the expected return or the expected cash flow. If we look at Crosley, we'd go through the same mechanics, the same computation, and in this case the expected is 33. My expected return is 33. I would go through, determine the variance, determine the standard deviation, determine the coefficient of variation is 0.17. So, the decision will come down if I have an aversion to risk. I don't want to take risk. I want to get the expected mean or the expected cash flow, but the greatest possibility of earning. I would go with Crosley due to the fact that it has the smallest coefficient of variation. Even though the expected return or the expected cash flow for Crosley is 33, which is less than 40, which I could get for Wrigley. However, there's going to be a greater certainty of getting the 33 with Crosley than getting the 40 with Wrigley, because of this 17 or 0.17 is significantly smaller than the coefficient of variation for Wrigley. Now, if I'm saying, okay, I don't care about risk, I'm going to take as much risk as possible, therefore we would go with Wrigley because it has the largest coefficient in the variation. Therefore, if risk is not a factor, I would take Wrigley. However, in business decisions as such, we have an aversion to risk. Therefore, we would always select those projects that have the least amount of risk attached to them.